Hi YouTube. My my symbolic name is Solo Size. What I'm about to show you guys is basic, but it will take you a long way. Okay. I'm a service engineer for 15 years. So if you want to subscribe for more details on some basic programming, you can send me an email or you can call me on the following phone numbers. Okay, so that's I see how I can help you in PLC. Step 7 300. So for those that are in Nigeria, you can call me 081 5799 2954. Those outside Nigeria can call me plus 234 8157992954. The main reason of this video is to optimize those that want to learn step 7 PLC 300, then at the same time WinCC or SCADA, whatever. Okay, so this is my step 7 page. The first thing we're gonna do, we select a new project. I will not do more of talking, just follow what I'm doing. Let's call this project direct online starter for motto, basically, because the motto we are going to do the direct online is not a motto with a downforce or a frequency converter. It's just a basic motto to start our conveyor and stop our conveyor. Okay, so now we insert our station 300. Double click the hardware. Okay, these are basics which at least many people will just follow what I'm doing. These are just basic stuff. We have 11 slots. Basically, slot 1 is meant for power supply, slot 2 is meant for the CPU, slot 3 is the expansion module, 4, 5 till 11 are meant for various use, whether digital or analog output. Okay, so what we're gonna do, let's just concentrate on the CPU. Let's leave the power supply for the moment. Let's take a CPU with a PN Ethernet. Let's try Ethernet, for example. Okay, let's network this guy. Let's rename it to conveyors. Okay, good. So this CPU has digital input, digital output, and we have analog input and analog output and positioning. Okay, so this is our main CPU, 314C2 PNDP. Okay, then you save and comply, basically. Okay, we close this project. So what we're going to do now, we're going to open our blocks wherein we can write the program for the direct online. But let me just give you guys the insight of what I want you guys, let's work on. It's just a direct online. Maybe when you subscribe, then you see more videos, especially those that are in Nigeria. that really want to learn step 7, I've given you the contact number which you can call, so that we see how we can arrange ourselves. If you are in Nigeria, you can call me on 081 5799 2954. If you are outside Nigeria, you can call me my plus 234 81 57 99 2954. Okay, so basically our target is to, what is this, is to show you guys basic skills, how to write a simple direct online starter for just a motor. Okay, basically that is what I want us to do. Desktop. Okay, this is what I want us to focus on this video. This is just part 1. For those that are electrically inclined, they understand that this is the power circuit, this is the isolator or circuit breaker, these are the fuses, contactor, overload, and the motor. This is the control circuit. You press this button, the contactor energizes, then the motor starts spinning, then the lamp starts coming on. So what we're going to do, we're going to write a program, a step 7 program, very simple and very precise. Okay, right. So now the first thing, we insert a function block. The function block, let's say function block 40, for example. Symbolic name, maybe direct online. Yeah, it's a direct online starter. Okay, so most of our parameters, we're going to write it on FB to 40. Open FB 40. Let's say start, stroke, stop, conveyors. Okay, let's open our environment interface. We type in all the inputs we need. At least we need automatic, manual mode. We need to start the conveyor in auto mode, and we need to start the conveyor too in manual mode. Okay, we need to stop the conveyor in the event of fault. We need to insert emergency stop, e-stop, as an input. We need to, okay, if there is an event of high current trip, we need to reset this guy in the event of fault. And maybe there is a sensor along the line that when my conveyor has backup, stop. So let's comment on these variables in the input. Automatic start, for example, or automatic start, manual start, start conveyor auto mode, start conveyor manual mode. Okay, stop Coveo. And this is emergency stop button. Also, emergency stop activated. And this trip is overload in case there is high current, so maybe you have stress on the conveyor belt. Let's overload. This one, general reset. General reset. And this is a sensor for backup. Okay, these are our input variables. What we need in the output, basically, you can add your own. I don't know. Let's say the contactor, the main contactor output, which I can just abbreviate as contact, and trip in case of there is fault. Trip out. The next is my conveyor ready. The next, if my conveyor is running, okay. So main conveyor output. This is message conveyor trip. Okay, this is conveyor ready, and this one is conveyor or motor, whatever you put. Conveyor fit. Conveyor running. Okay, then on the temp, maybe we say motor underscore trip. Okay, so now these are the variables we just insert. So now what we're gonna do, we're gonna write the program in FB40. So this one is to automatic stroke manual mode. Okay, you can subscribe. This computer is just crazy. Subscribe by sending me a mail okay, or you call me on this number within Nigeria. Zero 081 081 5 outside Nigeria, calling +234. Sorry. Outside. Okay. 94, 97 at Yahoo. Oh, I don't know what this. You can send me a mail, nyake94 at yahoo.com, or call me on this number within Nigeria. You call me on this number, or outside Nigeria, you can call me on this number. Okay. So basically, let's start our program. First of all, I'm going to nest. Nesting. Nesting means I don't want to complicate my program. Okay. So our nesting. Okay. The first is this one, auto. And nesting. And auto. And start auto. Oh shit. Oh, start underscore auto. That is, I start my auto, switch my select or whatever, or HMI on auto, then I have to hit on this button, start auto. Or it's optional. Or manual mode and manual, start manual, start underscore manual. Set me a memory marker 100.0, for example. Let me edit this memory marker, for example, marker 100.0. That is memory for auto stroke manual. Okay, and this marker, because like we are doing flip-flop, then set my output, which is count underscore out. Set my output, this one, main conveyor out. Okay, then and auto, because we want to start the conveyor. I want to see a bit that I'm ready. When the main contactor is on, I'm ready, or I'm running. So if the contactor is on, that means there must be an indication that I'm running. So we are doing for running. Okay, and auto and start auto. Okay, or manual, okay, and start manual mode. Set another marker, 100.1 memory marker. Why? What I'm trying to say, when this contactor is on, then this running must be logic 1. So that is what I'm writing. At any time the count out is logic 1, definitely run will be logic 1. Okay, so yeah, so on this marker 100.1, then set run. That means we are running. Okay, then I can close my nesting because I don't want to complicate issue. Now this is basically, if I hit on my auto, I hit on my start, this is automatic mode. Or if I hit on my manual mode, I hit on my manual start, it's going to set this marker 100.0, and anytime marker 100.0 is logic 1, my count out is going to be logic 1. That means my contactor is going to energize. Okay, straight the motor will start to rotate and your conveyor will start to run. When my auto is logic 1, I start on auto logic 1 or manual logic 1, manual start logic 1. I'm going to set this marker, memory marker, and anytime this memory marker is on, it's going to tell me that I am running. So when we start, if my count out is logic 1, definitely my run will be not logic 1. Now the condition that we're going to stop this conveyor is when I close this nest. So these are the conditions that will stop the conveyor. Condition number 1, if I hit on the stop button, it will stop my conveyor. Or if there is a trip or overload, it will stop the conveyor. Or if they hit the emergency stop, he stop, and he stop, it's going to stop the conveyor. Or if I have a backup for my sensor and sensor, it's going to stop the conveyor. So with all these 4 variables, anytime any of these variables stop, they stop logic 1, or trip logic 1, or e-stop logic 1, or sensor logic 1, is going to reset the memory marker 100.0, which is responsible for our both auto and manual. It's going to reset this marker. Okay, and it will reset, sorry, count out, it will reset, shit, don't know what is wrong with this laptop, count out. Okay, that means anytime there's the stop button is being energized, there's a trip, there's an emergency stop being activated, or a sensor has a backup, my count out is going to reset. At the same time, it's going to reset marker 100.1, which is responsible for run, that my conveyor is running. This one going to reset this guy, which is responsible for running. Anytime this one, anytime this one is running, the count out to this one will be running. But if we hit on the stop, there is a trip. Emergency stop is being activated. There's backup of the sensor. All this marker 100.0, 100.1, they are going to reset the main output. Reset, run, they will nullify NOP0. Okay, NOP0. Okay, so this is our condition to start this conveyor in manual and automatic mode. We take another network. Okay, if we have overload, let me say overload, let's name this one overload. Okay, for example, if we go to the hardware configuration, okay, on this hardware configuration, these are the inputs we have. Inputs 136.0 to 136.7. So I'm going to take 136.0 to represent my trip. Is just an input I need right now. So input 136.0 and which if I edit 136, and let me just say S100. Let me say trip contacts. It's just a contact also. If input 136.0 is activated, set me a marker, set me marker 20.0. That is, give me a memory marker that will store this activity anytime input 136.0 is being activated. Is gonna trip the motor or your conveyor will stop. Okay, so you add this marker and marker 20.0, then it's gonna give us our motor trip, motor underscore trip. Remember, the motor underscore trip is on the temp. Okay, this one, the temp. If we add motor is my vid, if we add sorry for the poor quality of the video, because I'm using Camp Studio. It's always like this. If we add this motor trip, it's gonna give us trip out as an output. This one, trip out. Okay, what I'm trying to say, anytime I have a logic 1 at input 136.0, this marker 20.0 is going to set, and anytime this marker is and 20.0 is going to give me an output of motor trip. Since this motor trip is logic 1, then this trip is going to give me a logic 1 that we're going to give me an output of trip out, which is our output message here, message conveyor trip. Then we need to reset it. If we and reset, anytime reset is and, then reset this marker 20.0 and reset moto underscore trip. Okay, so this is for the overload. What else are we going to write? Is it like conveyor is ready? Yes, let's take for conveyor ready. Then after that we write the program and simulate it for us to see. Conveyor ready. Okay, for my conveyor to be ready and not e-stop, that means don't activate emergency stop. If it is activated, my conveyor is not ready. And not trip. Oh shit. Not trip. Do not trip. If there is overload, my conveyor is not ready. And not sensor. No backup. If there is backup, my conveyor is not ready. After getting all these facts, set me a marker, memory marker 20.1. Okay, and this memory marker for me. Then my conveyor is ready. My conveyor is ready. But if my main contactor is on, that's this one, count out, my conveyor ready, we switched off because now I'm running. Okay, the conveyor ready is just a signal to tell us that there is no fault along the line. I can start my conveyor to start running. So that means if I count out, that is the main contactor, reset the memory marker 20.1, then reset ready. Okay, so let's stop here for the moment and save our work. Save. Okay. Okay. Now we close FB40. We open another block, a function. Let's see, FC7 DOL, direct online. This time around a ladder. So what I'm going to do, all these parameters that has been written, we just wrote just now, all these parameters, start, stop. Don't forget, this is my mail if you want to subscribe. All these parameters that has been written, we're going to call them in FC7. Okay, don't forget to subscribe. Now let's see, start stop conveyor. This camp studio is a problem. Okay, click on this segment. Now locate your function block in this region, open the folder, then you double click on the block 40. This is what we have on block 40. So you create an instant data block, let's say DB40. It's going to bring a dialog box that I want to create. Yes, we create an instant data block that will have all the parameters we needed. So if we come to the basics, we open DB40. This is our instant data block. This is where all the parameter we needed Now auto, I'm not on auto, so it's false. Manual is false because I'm not yet online. Okay, so let's start to edit this block. The first thing we're supposed to do is auto. We need a bit from the HMI that when I press the bit, my conveyor will be in the position that there is no problem. There is no problem about emergency stop. There is no problem about overload. I am in the automatic mode. So we open DB40, so instant data block. The bit is DB40 DBX 0.0. That is our automatic start. So DB40 dot DBX 0.0. That is the bit to start automatically. The bit for manual is 0.1 DB40 DBX 0.1 DB40 dot DBX 0.1. Okay, to start automatically, that is this one, start automatically, that is 0.2 DBX40 DB40, sorry, DB40 DBX 0.2. Okay, manual mode 0.3 DB40 dot DBX 0.3. Now the stop button, stop is 0.4 DB40 dot DBX 0.4. So we edit this guy, right click, edit, let's say DB40, start auto. Just want to edit the block. Now this is our block. Okay, direct online starter, as you can see, and our instant data block is DB40. So now this is our block we are trying to edit. For emergency stop, the input, we go to the hardware configuration. Let's say the input is 136.1. Input 136.1. And trip input 136.2 from the hardware configuration. Reset. Let's take a bit from the system, from the hardware configuration, or we can take from the instant data block DB40, which is this one. Stop, reset. Reset is DB40 DBX 0.7. DB40 dot DBX 0.4, and the input of the sensor, input 136 point dot 136.3. Okay, we can edit this one. Let's say S11 frequency. Stop. And this one. Edit this one. Let's say B101 is just a symbol. The sensor for backup. Don't forget to subscribe on these numbers above. So now the output here is from our hardware configuration. We have output of 136.0, so our output here is Q136.0 or 136.0. And trip out, let's represent it to be marker 10.0. Later I will explain. Then marker 10.1, marker 10.2. Okay. Edit this one. I'll say M11. Main contactor for conveyor, for example, M11. Okay. Oh la la. Now we are set. So you can see you save this guy. We started initially from this one, FB40. We wrote the program. We insert our variables for inputs. If you can remember, this is just a recap. We insert the outputs and the temp, and we wrote the program together. Now we're going to simulate the program. Okay. So what we're going to do now, we're going to open OB1. Then we're going to call FC7. Okay. Save. But we need to write a small program for always, let me see, always off. Always off. And marker 0.0. Give me marker 0.0. I'm always off. Okay. Then always on. R0 marker 1.0, for example. Set marker 200.0 is a flip-flop. I'm just writing. That means anytime I am R0, set this marker 200.0 and the marker 200.0. Then give me an output of marker 1.0. Then I nullify this guy. Okay. And save. Okay. Now we open our simulator. Let's see if we can run this program. This is the part 1 of my tutorial. If you want to subscribe, you can call me or you can email me. Okay, so we're gonna end part 1 after the simulation. Then the part 2 tutorial, I'm gonna show you from the WinCC HMI, how it's going to affect our program from the WinCC. So we insert our inputs, I think is 136, and we have an output 136. Okay, then we download these guys. Let's see what will happen. Unable to reach module. Yes, because on our hardware configuration, right click, property. This module is on Ethernet. So what we're going to do, option, set PC interface is on Profibus. No, we go to TCP IP address because it's Ethernet. Say yes. Let's see if you can download for us. Download. Yeah, it's downloading. Okay, we are there. Let's run our simulator and see what will happen. Our simulator is ready. We open FC7. We go online. Now you can see we are running. Okay, so from OB1, always on, go online, always on. So we can activate our block by opening contact, marker 1.0, which is edit this one. Let's say always true. Download, save, download. Okay, now you can see we have a logic 1 here. That means I am ready to run. There is a logic 1 here. I am ready to run. Okay, but for me to start, I need a bit DB40 DBX 0.0 in automatic mode. Then I need another bit DB40 DBX 0.2 to start my conveyor. So thanks for listening and thanks for watching. This is part 1 of direct online tutorial. This is my email, nyake97@yahoo.com, and this is my contact. Okay, thank you for watching.